We're going to work on half-life problems. Half-life is the time it takes for 1/2 of a sample to decay, and we're going to use radioactive isotopes in our examples. Factors such as temperature, concentration, and pressure have no effect on half-life, so each radioactive isotope will have its own unique half-life that is independent of any of these factors. We're going to set up our half-life calculations the same all the way through. We're going to always determine how many half-lives occur in the given amount of time, and then for each half-life, we're going to half the number of particles of the radioactive element. Let's take a look at an example. If there are 60 grams of neptunium-240 present, how much Np-240 will remain after 4 hours? Np-240 has a half-life of 1 hour. We're always going to start off with our given information. 1 half-life is equal to 1 hour. And they're asking how much will decay after 4 hours. So we're going to have to convert 4 hours to half-lives. If hour is in the numerator, then hour goes in the denominator. We need to have a relationship between half-life and hour. 1 half-life is equal to 1 hour. Hour cancels out with hour, and we're left with half-life. So this will equal to 4 half-lives. We started off with an original sample of 60 grams, and these 4 half-lives means that we're going to multiply 60 by 4 1/2. This will equal to 3.75 grams of Np-240. So if we started off with 60 gram sample, after 4 hours, this would decay to 3.75 grams of Np-240. Let's take a look at another example. A sample of actinium-225 originally contained 8 micrograms. After 720 hours, how much of the original Ac225 remains? The half-life of this isotope is 10 days. We always want to start off with our given. 1 half-life is equal to 10 days. They're asking about a time frame of 720 hours. So we're going to have to convert 720 hours to half-lives. If hour is in the numerator, we're going to have to put hour in the denominator. Our half-life is in terms of days, so we're going to convert hours to days. 1 day has 24 hours. Day is in the numerator, so now day is in the denominator. We have a relationship between days and half-life. 1 half-life equals to 10 days. Hours cancel out, days cancels out, and we're left with half-life. So this will equal to 3 half-lives. Our original sample was 8.0 micrograms. 3 half-lives means we're going to multiply by 3 1/2. This will equal to 1.0 microgram of Ac225. Let's take a look at another example. How long will it take for 18 grams of radium-226 to decay to leave a total of 2.25 grams? Ra226 has a half-life of 1,600 years. So I'm going to always start off with my given. 1 half-life equals 1,600 years. Now this one is going to go in the opposite direction. They've given us an original sample of 18 grams and it decayed to 2.25 grams. And we want to know the time. So we started off with 18 grams and it decayed to 2.25 grams. I want to know how many half-lives did that occur in. So we're going to keep multiplying by 1/2 till we get to 2.25. So 18 times 1/2 is 9. 9 divided by 2 is 4.5. Divided by 1/2, or times 1/2 is 2.25. So this happened in 3 half-lives. However, they're not asking about the half-lives, they're asking how long would this take. If 1 half-life is 1,600 years, then 3 half-lives is going to equal to 4,800 years. So 18 grams will decay to 2.25 grams in 4,800 years. Let's take a look at another example. How long does it take a 100-gram sample of radioactive isotope with a half-life of 33 seconds to decay to 6.25 grams? All right, we're always going to start off with our given information. 1 half-life is equal to 33 seconds. We started off with 100.0 gram sample, and over some time it decayed to 6.25 grams. I want to know the half-lives it takes to go from 100 to 6.25. So 100 times 1/2 times 1/2 times 1/2 times 1/2 will equal to 6.25 grams. These are 4 half-lives. One half-life is 33 seconds. So 4 half-lives is going to equal to 132 seconds. So we can go in both directions with half-life problems. Good luck and keep practicing.